So a particle moving with velocity v bar is acted by three forces shown by vector triangle PQR. The velocity of particle will: option A, change according to smallest force QR, increase, decrease, remain constant. Tell me what's the answer? Look at those three forces. Yes,
Remain constant.
remain constant because what?
Net force of the particle is 0.
Right. So net force acting on the particle is 0. Okay. So see, if you think that this is the first force, okay, so this is first vector, then this is second vector, and this is third vector. So you are ending at the same point where you started, right? So sum of these three forces, it's equal to what? 0. Okay, and therefore net force is 0. So the velocity of particle will not change. There will be no acceleration. Okay, so option D is the answer. This was simple. Okay, next one. Three forces acting on a body are shown in the figure. Okay, there are three forces. 1, 2, 3. To have resultant force only along y direction. Okay, you want resultant force only along y direction. The magnitude of minimum additional force needed is. Okay, so what is minimum additional force that you will need? Right. So let's find out the force in x direction. Okay, you want force in y direction. That means the net force in x direction must be equal to 0.
Yes, sir.
Okay, so let's find net force in x direction. So this angle is 30 degrees. That means this angle is 60 degrees. This angle is 30, so this is also 30. So this will be 60. Okay. So now, what is force due to this force Newton? Sorry, force due to this 4 Newton. Okay, the component of force in x direction. How much is that? It is 4 multiplied by cos of 60, and it is acting towards left. So we'll take it as negative. Due to this 1 Newton, it is 1 cos of 60.
60 degree.
Okay, and due to this 2 Newton, can you see this? Due to this 2 Newton,
2 cos 60
2
degree.
cos 60 degrees. Okay, so what is the net force? It is 1 cos 60, or cos 60 you can take common. Cos 60, so net force in x direction is cos 60 multiplied with 1 plus 2 minus 4, right? Because these components are towards right, this one is towards left. Okay, so this is equal to cos 60 is 1 by 2. So it is 1 plus 2, 3 minus 4. Okay, 3
0.5 newtons.
0.5 newtons, right? So answer is minus 1 by 2 will be the net force acting, and you want to cancel out that. So you need additional force of 0.5 newton, right? So this was also simple.
Yes, sir.
Yes, sir.
Okay. So then let's see this next question. A stone is dropped from height h. It hits the ground with a certain momentum p. If the same stone is dropped from height 100% more than the previous height, okay, the momentum when it hits the ground will change by. Stone is dropped from some height. It hits the ground with momentum p. Okay, so p equals to its mass multiplied by velocity. So how much would be magnitude of velocity when an object is dropped from height h? It is square root of 2gh.
2 G
2g,
H.
right? Okay, so you know this formula.
Yes, sir.
Yes, sir.
Okay, so v is equal to square root of 2gh. So let's call this one h1. Okay, so v1 is to v2 will be equal to what? Okay, and therefore now momentum is mass times velocity. So p1 by p2 is equal to what? It is mass multiplied by velocity. Okay, so m is constant. Okay, so m will get cancelled, multiplied by velocity, which is square root of 2gh. So here g and g will get cancelled. Ratio of v1 is to v2 is h1 is to h2. So mass gets cancelled, right? So you have, so initial is suppose some height, h2 is equal to what? This 100 times, sorry, it's not 100 times, 100% more. That means it will be equal to 2 times h1. Okay, so this is h1 divided by 2 times h. Okay, so this thing gets cancelled. So 1 upon root 2. Okay, so p2 is equal to, you can say, root 2 times p1. What is root 2?
1.414.
1.41. Okay, so if p1 is 1, this is 1.414. So how many percent more? 41%. 41.4% more. Right? Yes, no?
Yes, sir.
Yes, sir.
Okay, you got this, or we have to calculate that?
No, sir. Got.
Got it.
Okay, or you can do p2 by p1. Okay, p2 by p1 is 1.414. You can multiply that with 100. Okay, so you will get 141. So if p1 is 100, that means p2 is 140. Okay, so this is clear, right? Simple question. Okay, next question. So this was from JE. This is from NEET 2009. Okay, a body under action of this force acquires an acceleration of 1 meter per second square. The mass of this body must be. So this is very simple, right? So force. So first of all, find out magnitude of force. So force is equal to mass times acceleration. Find out magnitude of force. So F is equal to what? Square root of Fx square plus Fy
Sir,
square.
10 root 2.
Okay, you calculated, good. So this is equal to square root of 6 square plus minus 8 square. Okay, or 8 square plus 10 square. So how much is this? This is equal to square root of
200, sir.
200, and this is equal to 10 root 2. So they should have at least given some, okay, acceleration is equal to 1. Okay, that means force is equal to mass. So at least they should have given some value, okay, to acceleration, root 2 at least. Anyways, so very simple question, 10 root 2 is the answer. Good. Force of 6 Newton acts on the body at rest and of mass 1 kg. Okay, so you have force, you have mass. That means you have acceleration. During this time, the body attains a velocity of 30 meters per second. Okay, the time for which the force acts on the body is. So what is acceleration? It's force upon mass. Okay, 6 divided by mass is 1. So 6 meters per second squared is the acceleration. A, the body is initially at rest. So u is equal to 0. Okay, and v is equal to 30 meters per second. So this one was simplest,
Sir,
I guess.
5 seconds.
Right, 5 seconds.
Yes,
Okay,
sir. 5 seconds.
good. So a equals to v minus u divided by t. T equals to v minus u divided by a. Okay, so 30 divided by 6, right? 5 seconds. 5 seconds is the answer. Okay, so this was back in 1997. A 600 kg rocket is set for a vertical firing. If the exhaust speed is 1000 meters per second, the mass of the gas ejected per second to supply thrust needed to overcome the weight of the rocket is. Okay, so you want to overcome weight of the rocket. Okay, so what's the formula here? Force is equal to what? Dm by dt. For rocket, it is dm
dm
by
by
dt
dt
multiplied with
into v.
v. So mass of the rocket is given. Okay, and so this is suppose the rocket, its mass is given, m is its mass suppose. Okay, it is 600 kgs. Let's call it capital M. Okay, this is dm by dt is for exhaust gases, small m is for exhaust gases. Okay, so this is the mass, and what do you want to do? So the mass of the gas ejected per second to supply the thrust needed to overcome the weight. Okay, so weight acts vertically downwards. You want an upward force just to overcome the weight. That means the up thrust given by the ejected gases should be equal to what? Weight of the rocket. Okay, so up thrust is equal to what? M multiplied by G only. This is clear. How does that M
Yes,
into
sir.
G comes? Okay, so this is
Yes.
equal to dm by dt multiplied with V. So we have mass of the rocket, we have G, of course, it's 10, and exhaust speed V is how much? It is 1000. So let's put the values. So mass is 600, G is 10, and we want to find out dm by dt. What is V? It's 1000. So this is
So
6000
6
divided by,
kg second.
right. So 6 kg per second. This is the answer. Okay, this is clear.
Yes, sir.
Okay, good. Next question. Again, this was in 1994. In a rocket, fuel burns at the rate of 1 kg per second. This fuel is ejected from the rocket with a velocity of 60 kilometers per second. This exerts a force on the rocket equal to, this is direct question, right? So F is equal to
Yes.
dm by dt multiplied with V. So dm by dt is given 1 kg per second. Fuel burns at the rate of 1 kg per second. Okay, and this fuel is ejected with this velocity 60 kilometers per second. So what's the answer?
So 60,000 newtons.
Yeah, 60,000 Newton, because this is 1 kg per second and this is 60 kilometers per hour. So it is 60 multiplied by 10 raised to 3 meters per second. Good. So 60,000 Newton is the answer. Okay, next question. If the force on a rocket moving with velocity of 300 meters per second is 200 Newton, then the rate of combustion of the fuel is. This is also similar. Okay, so force is given. Force is dm by dt multiplied with V,
So 0.7.
0.7, right?
Yes, sir.
Let me check. Force is 210 Newton. So this is 210 Newton, and you want to find out dm by dt, right? So dm by dt multiplied with V is 300. So 210 divided by 300, 0.7. Good. So this is the answer. Okay. So a lot of questions are repeated on rocket. Okay. So where velocity is constant, mass is changing, right? So next question. Sand is being dropped on a conveyor belt at the rate of m kg per second. The force necessary to keep the belt moving with a constant velocity v meters per second will be. Okay, so here you have a conveyor belt like this. So this belt, it keeps on moving. Okay, keeps on moving like this with some speed v. V is the speed. And now you are dropping some sand. You're dropping some sand on this conveyor belt. Okay, and you are dropping it at the rate of m kg per second. So what will happen due to this extra mass? What will happen? The belt will slow down, right? The extra mass is being deposited, so mass is changing. It will slow down. Now you don't want
Yes, sir.
it to get slowed down, so you will keep on exerting some force such that it doesn't slow down. Its speed remains constant. Okay, its velocity remains constant. So what can you say? F is equal to what? Dm by dt multiplied with v. Okay, you want v constant, mass is changing. Okay, so force is equal to dm by dt multiplied with v. Okay, so same idea as that of the rocket, but applied to a different case. Okay, this is clear. So what is dm by
Sir.
dt? Dm by dt is m.
M.
M times v
So
is the answer.
MV Newton.
Right, mv Newton is the answer. Good. Okay, so a satellite in a force-free space sweeps stationary interplanetary dust. Okay, so there is no gravitational force at the rate of dm by dt equals to alpha times v, where m is the mass and v is the speed of satellite and alpha is some constant. The acceleration of satellite is, this is the question. Okay, so it is moving with constant speed v. V is the speed and m is the mass. Okay, and some dust is getting deposited, right? Dust is getting deposited. So due to that dust, what will be the acceleration? This is the question. So again, you can say F is equal to what? This dm by dt multiplied with v, right? Because some mass is
Sir,
getting.
option D.
Option B,
D.
D. Okay, let's check. So
Yes.
force is mass times acceleration. Dm by dt is alpha times v. Okay, but now since,
Minus.
yeah, so why minus? Because acceleration will be negative because mass is getting deposited, so it will slow down. Okay, so
Okay.
alpha times v multiplied by v, alpha times v square, right? So it is a is equal to minus alpha times v square divided by m, right? So option D is the answer. Good. So this is again similar question.
Sir.
Okay, so lot of questions have been asked based upon this thing. A cricketer catches a ball of mass 150 gram in 0.1 second, moving with speed of 20 meters per second. Then he experiences a force of. So this is very simple, right? He catches a ball. Okay, so final velocity of ball will be 0 in 0.1 second. So mass is given, time is given, and the ball was moving with 20 meters per second. So it's simple. So F is equal to mass multiplied by acceleration. Okay, so it is m multiplied by final velocity minus initial velocity divided by time. So it is 150 grams. So 150 multiplied with 10 raised to minus 3. V is 0 minus u is 20 divided by time is 0.1. Okay. So what is that? 20 times 150 is 3000 multiplied by 10 raised to minus 3 upon 10 raised to minus 1. So 10 raised
Sir,
to minus
30
2,
Newton.
30 newtons. 30 newtons would be the answer. Good. Okay, so this is from NEET 2001. Very simple question. Okay, a particle of mass m is moving with a uniform velocity v1. It is given an impulse such that its velocity becomes v2. The impulse is equal to. Okay, so impulse is force times force multiplied by time. Okay, so we'll talk
Yes,
about the impulse. But impulse is force multiplied with time if force is constant. So force is equal to what? M into v2 minus v1 divided by time. Okay, take the t on other side. So if force is constant, so you get m into v2 minus v1, or you can say this is average force. What is impulse? It is force multiplied with time. So it's this thing, m into v2 minus v1. Okay, so impulse is equal to change in momentum. So this is direct question actually. So the force acting on a particle of mass m is indicated by force time graph as shown. The change in momentum of the particle over the time interval from 0 to 8 is. Okay, so what will be change in momentum? It is area under this curve. But now there is one very important thing to be remembered, that we'll take area under the curve, but area above the x-axis is positive and area below the x-axis is negative. Right? Area above the x-axis is positive and area below the x-axis is negative. Okay, so let's find out the area. Can you see this? The change in momentum will be area under this curve. This is force on y-axis or vertical axis, and it is time on the horizontal axis. So area of this triangle is half of base multiplied by height. So its base is 2, height is 6. 6 times 2, 12. 12 divided by 2, 6. Minus this area. So this is 3 times 2. So minus 3 times 2. Okay. Plus this area. This area is, this is 4 times 3. Okay, so 3 times 4. So it is 6 minus 6 plus 12. So it is 12. So answer is 12 Newton second. Right?
Yes, sir.
Yes, sir.
Okay. This was simple question.
Yes, sir.
yes, sir.
Okay, the next one. The force time graph for a linear motion of a body initially at rest is shown in figure. The segments shown are circular. These are circular segments. Then the linear momentum gain in 4 seconds is. Okay. So what will be linear momentum gain? So they are asking in first 4 seconds. If they had asked in 8 seconds, what would be the answer?
0, sir.
It will be
0.
0, right? Because this area is negative and you have same positive area. Okay, equal positive area. So negative and positive gets cancelled. Okay, so up to 4 seconds, it will be what? Pi r square divided by 2, because this is semicircle, right? And how much is r? So you can see r is equal to 2.
Yes, sir.
Yeah, r is equal to 2. So it is pi multiplied by 2 square upon 2. So 2 pi, right?
Option C, sir.
Option C.
Yes, sir.
Okay. Next one. A particle of mass 2 kg is initially at rest. A force acts on it whose magnitude changes with time. The force time graph is shown below. This is the force time graph. The velocity of the particle after 10 seconds is. Okay, so it initially starts from rest and its mass is 2 kg. So this graph, the area under this graph will give us what? Change in momentum. Right? It will give us final momentum mv minus initial momentum mu. Okay, so initial momentum is 0 because it starts at rest. So this term is 0. So it gives us mass times velocity, mass times final velocity. Okay, area under this graph, right? So let's find out the area. So how much would be the area? So this is what half of 10 times 2. Okay, it is 10 times 2. So this is 10 plus it is this 2 times 10. 2 times 10. And after that we have a trapezoid. So what is the area of trapezoid? It is half of sum of parallel sides, okay, multiplied by base. Yes, no? Okay, sum of parallel sides. So it is 10 plus 20. Okay, 10 plus 20 multiplied by base is 2. So this is 30, 30, and this 2 and 2 gets cancelled. So this thing is 30 plus this area, half of base times height. So 20 multiplied by, okay, this is 4. Okay, 10 minus 6. So it is half of 20 multiplied by 4. Yes, so how much is total? So it is 10 plus 20 plus 30 plus 40. So 40 plus 40 plus 20. 100? No.
Yes, sir.
Okay, so this is 100. So this is 100 and its unit will be what? Kg, kilogram, meters per second. So this is mass times velocity and you want its final velocity, right? The velocity after 10 seconds is. This is mass times velocity. Mass is 2. So 2 times v is this. So how much would be velocity? Velocity is 50. Okay, 100 divided by 2. So this is the answer, right?
Yes, sir.
So these are simple questions.
Yes, sir.
A body of mass m hits normally a rigid wall with a velocity v and bounces back with the same velocity. The impulse experienced by the body is
2 MV.
2 mv, right? 2 mv is the answer. Okay, this is simple. You have a rigid wall, and a body hits this wall with some speed v. Okay, so its momentum is mass times velocity, and it bounces back with the same velocity. So the final momentum is also same, but it is in reverse direction. Okay, so you call this one positive and this one negative, or this one positive and this one negative. But how much would be change in momentum? So if I call this one positive, final positive and initial negative. Okay, so change in momentum. This is P2, this is P1. So P2 minus P1 is equal to mv minus mv, and that's equal to 2 times m into v. Okay, so this is the answer, 2 mv. Simple question. Next question. A rigid ball of mass m strikes a rigid wall. Okay, rigid ball of mass m strikes rigid wall at 60 degrees and gets reflected like this without loss of speed. So speed remains constant. The value of impulse imparted by the ball on the ball will be. So this one. So in this one, see, this is from NEET 2016. So this ball strikes on the wall. How much is its initial momentum? It is m times v. Okay, what is the direction? It's in this direction. So we can resolve it along two components. Okay, so this kind of question has been repeated. So see, now this angle would be, how much would be this angle? So since this angle is 60 degrees, this angle would be 60 degrees. It is two parallel lines and these are the alternate angles, right? You
Yes,
have
sir.
two parallel lines
Yes,
and an intercept. So these are alternate angles. So they will be equal. So this is 60 degrees. This angle is 60 degrees. Okay. So initial momentum is in this direction. It's mv. Now you can resolve it. So this component will be mv cos of 60, cos of theta, and this is mv sine 60. And after it gets reflected from the wall, now again this is the total momentum. You can resolve it along two components, right? So this is mv. So this angle, now this angle is 60, this is 60. So this is mv cos of 60, because this angle is 60. This is mv sine 60. Okay, so now you can see the vertical component remains constant. When the ball hits the wall, the vertical component of momentum remains constant, and there is change in horizontal component only. And how much is the change? So if you call the initial this component as positive and this one as negative, then the change is P2 minus P1 is equal to minus mv cos 60 minus mv cos 60. So it is minus 2 times mv cos of 60. And what is cos 60? Half, right? So it is minus 2 times mv multiplied by half. So it gets cancelled. So mv is the change in momentum. So this is the answer, right? With negative sign, but sign is relative. Okay, so you could consider this one as negative, this one as positive. So then let's move on to the next question. A 0.5 kg ball moving with a speed of 12 meters per second strike a hard wall at an angle of 30 degree with the wall. It is reflected with the same speed at the same angle. Okay, it is reflected with the same speed at the same angle. If the ball is in contact with the wall for 0.25 seconds, the average force acting on the wall is. So this is also similar. See, the mass is given. So mass of the ball is 0.5 kgs. Speed is 12 meters per second, and it hits a hard wall at an angle of 30 degree with the wall. So 30 degree with the wall. So this is the wall, and the ball hits the wall at an angle of 30 degree with the wall. So that means this angle is 60 degrees. Okay, so the ball is moving like this, right? So if the ball is in contact with the wall for 0.25 seconds, so how much is the force? How much will be the change in momentum? So we just found it. It is similar to this question. 2 mv cos of 60, right? Yes, no?
Yes, sir.
Angle is
Yes,
also
sir.
same. Okay, angle with the wall is 30. That means this angle is 60. Okay, so there is change in only horizontal component and there is no change in vertical component. So horizontal component is how much? Cos of 60. Okay, mv cos of 60. So change in momentum is 2 times mv cos of 60, right? So cos of 60 is half. That means change in momentum is, so delta p is equal to 2 times mv cos 60, and cos 60 is half, so it's equal to mv only. So how much is force? Force is equal to mv multiplied by time. So that's 12. Okay, 0.5 is the mass multiplied by 12 divided by time, 0.25. So 0.25 in denominator means 4 in the numerator. Okay, so 4 times 12 is 48. 48 multiplied by 0.5, 24 is the answer, right? Option C is the
Yes,
answer.
sir.
Yes, sir.
Okay, so this was simple question. See, this kind of question, yeah, this is also similar. So this was very simple, straightforward. So these questions are repeated many times. Another one. Okay. A body of mass 3 kg hits a wall at an angle of 60 degrees and returns at the same angle. So this angle is 60 now. The impact time was 0.2 seconds. The force exerted on the wall is. Now, how much will be the change in momentum? Delta P. So if this angle is 60, this angle is 30.
Option A, sir.
You calculated? Very good.
Yes, sir.
Okay. So this will be mv cos of 30. So change in momentum is 2 mv cos of 30. Okay. So it is 2 times mv. Cos 30 is how much? Root 3 by 2. Okay. So mv root 3 is change in momentum and time of impact is 0.2. So F is equal to delta P divided by delta T. So it is mv root 3 divided by delta T is 0.2. And how much is mass? Mass is 3, velocity is
10, sir. In diagram they given.
yeah, in diagram they have given 10 meters per second, right? So 10 multiplied by root 3 divided by 0.2. Okay, so 0.2 in denominator means 5 in numerator, 5 times 10, 50, right? So 150 root 3 is the answer. Okay, good. So yes, so these are simple questions. Anybody can solve, right? So important thing is the time in which you solve, right? So here we can remember one thing. Okay, when it hits the wall, there is change in horizontal component only. Okay, so if you have angle with the horizontal, okay, whatever is angle with horizontal, that is important. Okay, not the angle with the wall, the angle with horizontal, right? If angle with horizontal is theta, then change in momentum is 2 mv cos of theta, right?
Yes, sir.
Okay, angle with horizontal
Yes,
is
sir.
theta, change in momentum is 2 mv cos of theta. Directly you can write change in momentum 2 mv cos of theta and divided by time is your force. Okay, if momentum is asked, then 2 mv cos of theta is change in momentum. Okay, right. So let's solve some problems based upon this. This is long back from 1998. A shell in flight explodes into 4 unequal parts. Okay, a shell in flight explodes into 4 unequal parts. Which of the following is conserved? Potential energy, momentum, kinetic energy, both A and C. So answer is
Option D.
Momentum, sir.
only momentum.
Yes,
Next
sir.
one. So a man fires a bullet of mass 200 grams at the speed of 5 meters per second. The gun is of 1 kg mass. By what velocity the gun rebounds backward? So this is very simple. So total momentum before firing is 0. It's equal to total momentum after firing. So after firing, it is mass of bullet multiplied by velocity of bullet plus mass of gun multiplied by velocity of gun. So mass of the bullet is given, the speed of bullet is given, and what else is given? Okay, 1 kg. There is no number, 1 kg. The mass of gun is given. Okay, so we can substitute that. So it is 200 grams means 0.2 kilograms multiplied by 5 plus it is 1 multiplied by Vg. So you can take this on left side. So it will be Vg will be negative of this. So 0.5 multiplied by 5. How much? 1. Okay, 1 meters per second is the
1
answer.
meter.
Right. 1 meters per second is the answer. Okay, the next one. This question, sorry, a mass of 1 kg is thrown up with a velocity of 100 meters per second. Okay, a mass of 1 kg is thrown up with the velocity of 100 meters per second. After 5 seconds, it explodes into two parts. One part of 400 gram comes down with a velocity of 25 meters per second. The velocity of other part is, right? So there is a mass of 1 kg. 1 kg, it goes up with the velocity of 100 meters per second. So it goes till this height, let's suppose, and after 5 seconds, it breaks into two parts. So it breaks into two parts at that height. Okay, here it breaks into two parts. One part goes down, okay, its mass is 400 grams. So definitely other part will go up. Yes, no? The other part will go up because it was moving up.
Yes, sir.
It was moving up. Okay, so let's find out with what velocity it was moving up. Okay, with what momentum it was moving up when it exploded into two parts, and then we can apply the law of conservation of momentum. Okay, so this mass of 1 kg moves up with velocity of 100 meters per second after 5 seconds. So what will happen after 5 seconds? So how much will be its velocity?
Breaks into two.
Yeah, it breaks into two. How much will be its velocity? We can use v equals to u plus at. It will be u minus gt because acceleration is minus g. It is moving up, acceleration is down. Okay, it is 100 minus g is 10 times 5. It is moving up with 100 minus 50, 50 meters per second. Okay, so net momentum now. How much is total momentum? Its mass is 1 kg. So momentum before explosion. Okay, so P initial equals to P final. Okay, so its mass multiplied by initial velocity is equal to, now there are two masses, m1 v1. What do I mean by this u, or I will call this v initial. Okay, which is this velocity before explosion, right? Its velocity is 50 meters per second. So this is 50. 50 multiplied by its mass is 1. So total momentum is 50. And after the explosion, one part of 400 grams comes down with the velocity of 25 meters per second. So 400, no, not 400, 0.4 in kgs multiplied by 25 plus this thing m2 v2. So how much will be m2?
0.6.
0.6, right? 0.6 multiplied by v2. So v2 we have to find out. So tell me, this will be 25 times 0.4, 10. Okay, 25 times 4 is 100. 25 times 0.4 will be 10. So take that 10. Yeah, and it is moving down. Let's not forget. This one is moving up. This is moving up. This one moves down, right? So it will have a negative sign here. So this is not 25. If 50 is positive, 25 must be negative. Yes, no?
Yes, sir.
Yes, sir.
Okay. So this is minus 10. Take it on other side. It will be plus 10. So 50 plus 10 is 60. So 60 is equal to 0.6 multiplied by V2. So what is V2? 60 divided by 0.6 or 600 divided by 6. It is 100 meters per second. Right? Option C is the answer. So let's move on to the next question. A body of mass 5 kg explodes at rest into three fragments with masses 1, 1, 3. Okay, 1 is to 1 is to 3. The fragments with equal masses fly in mutually perpendicular directions with speed of 21 meters per second. The equal masses 1, 1 and 1. Okay, so if it is 5 kg, then this will be 1 kg, 1 kg, 3 kg, right? So they fly in mutually perpendicular directions with a speed of 21 meters per second. The velocity of heaviest fragment in meters per second will be. So this is from 1989. Okay, but this question has been repeated. That's why I have taken this question. This question has been repeated 2, 3, 4 times. Okay, so we'll see that. All right. So we have 5 kg mass, which was initially at rest. It was initially at rest, and it explodes into 3 masses. The ratio of those masses is 1:1:3. Okay, the fragments with equal masses fly in mutually perpendicular directions. So let's suppose this is the body which breaks into 3 masses. So the fragments with equal masses, they fly off in these directions, let's say. Okay, so this is x, this is y. So this is 1 kg mass. This is also 1 kg mass. And this one is 3 kg mass. So if these two fly off like this one has to fly off in this direction. Yes, no?
Yes, sir.
Exactly at 45 degrees. Okay, because if you take momentum of this plus momentum of this, direction of momentum is what? If you resolve, if you take its resultant, then it will be in this direction. So this other mass has to move in the opposite direction to cancel out the momentum. How much is their velocity? So velocity of this one is 21 meters per second. Velocity of this one is also 21 meters per second. So its momentum. Momentum of this one is how much? Mass is 1 kg. So it is 21 I. Okay. Kg meters per second is the unit. And momentum of this one is 21 J kg meters per second. Okay, and sum of momenta of all three masses is equal to 0. So I can say total momentum before explosion is 0. 0 is equal to this mass. Okay, I can say m1 v1 bar plus m2 v2 bar plus m3 v3 bar. m1 v1 is 21 I cap. So this is 21 I cap plus this is 21 j cap plus m3 is 3 multiplied by v3. Okay, so take this thing on left hand side, so you will get so this is equal to 3v3 is 21I minus 21I plus 21j. Okay, can you see this negative sign? And then divide by 3. So if you divide by 3, it will be 7I plus 7j. Okay, minus 7I plus 7j. And you want its speed. So how much will be speed? Because no vector is given here. So how much will be speed? It is square root of vx square plus vy square. So it is square root of 7 square plus 7 square. 2 times 7 square, right? So 7 you can take out. It is 7 root 2. Okay?
Yes, sir.
Understood, or there is any confusion?
Yes, sir.
Yes, Soumya?
Yes, sir.
Okay, so 7 root 2 is the answer. Okay, then let's move on to the next question and see it is the similar question. Now, sorry. Now it is 1 kg mass. Okay, it's similar question. A 1 kg stationary bomb is exploded in 3 parts having mass 1:1:3. They have not changed the ratio also. Okay, parts having same mass move in perpendicular direction with velocity of 30 meters per second. Value is changed. The velocity of bigger part will be. So this is similar. Okay, so this is a bomb which explodes in 3 parts. So 2 parts move like this. Okay, so it is 1 kg. So let's suppose 1 kg equals to 5 m, because this is 1 plus 1 plus 1. Okay, so 1 kg equals to 5 m. So this is m times v in this direction, mv j cap, and this is m times v into I cap, right? Okay, and this mass which is 3m. Okay, 3m, it will move in this direction. So what is total momentum? Total momentum before explosion is 0. Total momentum after explosion will be 0. Okay, so net momentum is 0, and it is equal to what? I can say 3m multiplied by whatever its velocity. Okay, so let's suppose let's write it by capital V bar. It's equal to mv times I cap, sorry, plus mv times I cap plus mv times j cap. So sum of momentum of all 3 masses is equal to 0. So sum is equal to 0, right? So now we can move this mv into I cap plus mv into j cap on left side. So it will become negative. And even before that, we can cancel out m, right? So what do we get? We get 3 times v bar is equal to minus of vi cap plus vj cap. Okay, notice here I have written capital V, this is small v. So small v is given, it's 30 meters per second. So this is equal to 30 I cap plus 30 j cap, and this is 3 times v. Now if you divide it, you will get what? V bar is equal to minus of 10 I cap plus 10 j cap, and then you want the speed. So it is square root of vx square plus vy square. So square root of 10 square plus 10 square. So 2 times 10 square. Okay, you can take 10 out. So it is 10 root 2, right? Meters per second. This is your answer. So option A. Again, it was option A. Yeah, before also it was option A. Okay, so options are also at the same place, right? So this is simple.
Yes, sir.
Yes, sir.
Yes,
Okay,
sir.
let's move on to the next question. An object flying in air with velocity of 20I plus 25J minus 12K suddenly breaks into 2 pieces whose masses are in ratio of 1:5. The smaller mass flies off with velocity. This is the velocity. The velocity of larger piece will be. So we can say the initial momentum before breaking is equal to final momentum, right? So initial momentum, so now it is breaking into how many parts? 6 parts, or I can say total mass is 6m, it is breaking into 2 parts, right? So initial mass is 6m multiplied by initial velocity is this thing. Okay, 20I plus 25J minus 12K is equal to, this is the velocity of smaller mass. So smaller mass is m, the bigger mass is 5m. Okay, so velocity of smaller mass is given. So 100I plus 35J plus 8K plus we have 5 times m multiplied by v bar that we don't know, that we have to find out. And then we can cancel out m, m and m, right? So what do we get? Take this on left hand side. So this thing is how much? 120 I cap, 120 I cap plus 25 times 6 is 150, 150 j cap minus 12 6 are how much? 72.
72.
Right, 72 k cap. It's equal to 5 times this thing. No, this thing is left, right? It is 100I plus 35J. So 100I plus 35J plus 8K and plus 5V. So we have to move this on left, subtract it from this.
20 I cap.
Your option A.
You calculated?
Yes, sir.
Yes, sir.
Okay, good. So your calculations are faster than me. Good. So everybody calculated this?
Yes, sir.
Okay.
Yes, sir.
So option A. Good. Next question. An explosion breaks a rock into 3 parts in a horizontal plane. Okay. 2 of them go up at right angles once again to each other. The first part of mass 1 kg moves with a speed of 12 meters per second, and second part of mass 2 kg moves with 8 meters per second speed. Third part flies off with 4 meters per second speed, then its masses. This is the question. Okay, so now they have changed the values. Okay, this time, but it is similar problem. So the rock breaks into 3 parts. So first one, it is of mass 1 kg. It moves with 12 meters per second. Second, of mass 2 kg moves with 8 meters per second. So let's suppose this one moves with 12 meters per second in this direction, and mass of this one is m. Okay, this one moves in this direction. Mass of this one is 2 times m. Right? It is 1 kg, 2 kg. We'll write m and 2m. Okay, so m is equal to what? 1 kg. Okay, and this one goes up with 8 meters per second. So 8 meters per second. And third one moves in some direction, we don't know, and its velocity is 4 meters per second. Speed is 4 meters per second, not velocity. Okay, speed is 4 meters per second. So what do we have to find out? We have to find out magnitude of this momentum, right? Not the momentum, magnitude of the momentum. Why? Because speed is given here, not the velocity.
Yes, sir.
Okay, you got this? Okay, so
Yes, sir.
we have to find out magnitude here. So how much will be magnitude? Okay, so first of all, let's find out momentum of these two, and momentum of this one will be in opposite direction. So we can say momentum of this one is minus of what? This thing, 8 times 2. M is equal to 1, no? So it is 8 times 2 into I cap plus 12 times 1 into j cap. Right, and how much is its magnitude? So this is 16, this is 12. Okay, so magnitude of P is equal to what? 16 square plus 12 square, square root of
So 20.
20. Good. 256,
400.
yeah, 256 plus 144. Okay, so square root of 400, that is 20 kg meters per second. Okay, so magnitude of momentum of this body will also be equal to what? 20 kg meters per second, and its speed is given 4 meters per second. So how much will be its mass?
5, sir.
5. Right, it will have same momentum but in opposite direction. Yes, no?
Yes, sir.
Yes, sir.
Okay, so 5 is the answer, option D. Okay, so yeah, that's all for today. Okay, is there any question? A body of mass m is kept on rough horizontal surface. Coefficient of friction is mu. Horizontal force is applied on the body, but it does not move. Okay, so you are exerting some horizontal force, but it doesn't move. That means the horizontal force applied is less than the limiting value of friction. The resultant of normal reaction and frictional force acting on the object is given F, where F is. So this is very simple problem. It is from NEET, I guess 2019. Okay. So the resultant of normal reaction and the frictional force acting on the object is F. So our object is, let's suppose this is the object. So can you tell me which will be the answer?
Option B, sir.
Option B.
Yes, sir. Mu
No,
mg.
that is frictional force. This is not frictional force, okay? This is not frictional force. All right. So now you are exerting some external force and the block is not moving. That means the frictional force in this case, will it be limiting value of frictional force or will it be less than that? It will be slightly less, because if the external force is equal to limiting value of frictional force, the block will begin to move. Okay, so this is Fs. Fs is less than the limiting value of the static frictional force, which is mu s multiplied by mu s multiplied by normal reaction. And normal reaction in this case is how much? It is mg, because the block is horizontal. So this is n, this is mg. Okay, so mg balances normal reaction. So this is equal to mu s multiplied by mg. This is frictional force. And the question is, what is the resultant of normal reaction and the frictional force? So it is resultant of Fs, the frictional force, and normal reaction. So it is total contact
Sir,
force.
option C.
Yes, option C is the answer. Good. Okay, so this is R. R is equal to what? Square root of Fs square plus n square. And since Fs is less than or equal to mu s multiplied by mg, okay, so this is equal to mu s mg, sorry, mu s mg square plus mg square, and mg you can take out. Okay, so it will be less than or equal to that, because Fs is less than or equal to mu s times mg. So option C is the answer. So which of the following statements is incorrect? Frictional force opposes the relative motion. Limiting value of static friction is directly proportional to normal reaction. Rolling friction is smaller than sliding friction. Coefficient of sliding friction has dimensions of length. Tell me. Option D. Right. Coefficient of sliding friction has dimensions of length. This is incorrect. It's true. Yeah, it is dimensionless. Good. So see, frictional force opposes the relative motion. This is true. Limiting value of static friction is directly proportional to the normal reaction. We know this. Rolling friction is smaller than sliding friction. Rolling friction is least of them. Okay, so this is also correct. So this one has to be incorrect. Okay, because all other three are correct. Coefficient of sliding friction has dimensions of length. We can see this. Okay, so friction is equal to mu times normal reaction. So this is a force, this is a force. Okay, so dimensions of force and normal reaction, frictional force and normal reaction are same. That means mu is dimensionless. Okay, all right. So let's see this question. A box of mass 2 kg is placed on the roof of car. The box would remain stationary until car attains maximum acceleration. Coefficient of static friction between the box and the roof of car is 0.2 and g equals to 10 meters per second square. The maximum acceleration of car for the box to remain stationary is. So alright, there is a box which is kept on a car. Okay, so let's suppose this is car. This car will accelerate. So now when this car accelerates, what will happen to the block, the box? It will tend to slide backwards. Okay, actually it remains there, and this car will move forward, right? Okay, so it seems like it is accelerating backwards, but this will happen only when there is no friction. Okay, if there is some friction, then what will happen? This external force, okay, external acceleration, it should be more than what? Should be more than the opposing frictional force. The external force should be more than the opposing frictional force. Okay, yes, no, right? So now, see, the frictional force we can find out. The coefficient of static friction is given. It is 0.2. Okay, so frictional force, maximum frictional force is mu s multiplied by normal reaction. So because this is horizontal surface, normal reaction is mg. So mu s multiplied by mg. Okay, and the external force should be greater than or equal to what? This frictional force. Okay, so we can say, so m multiplied by, so external force would be greater than or equal to fs max. Okay, so that is m multiplied by a is greater than or equal to mu s multiplied by mg. So m and m gets cancelled out, and you can find out acceleration, which will be equal to mu s multiplied by g. What? Yeah, 2 meters per second square. Okay, so if acceleration is greater than or equal to 2 meters per second square, then this block will begin to slide. Okay, not before that. This is clear? Okay, simple question. Next one. A marble block of mass 2 kg is lying on ice when given velocity of 6 meters per second is stopped by friction in 10 seconds. Okay, so it is moving with velocity of 6 meters per second, but there is some frictional force. So there is some frictional force. So it stops in 10 seconds. Then the coefficient of friction is. Okay, so now we have to find out what will be deceleration due to this frictional force. Okay, so there will be some deceleration due to this frictional force. So we can find out that, so v square equals to u square plus 2 times, not this one, no, it stops in 10 seconds. Okay, so it stops in 10 seconds. That means v equals to u plus at we can use. We have time, we have initial velocity, final velocity is 0. Okay, so this is 0 is equal to 6 plus acceleration multiplied by 10. So how much would be acceleration? Acceleration is minus 0.6. Okay, take this 6 on other side. It will be minus 6. Minus 6 divided by 10. Minus 0.6 meters per second squared. This deceleration is because of what? The frictional force. Okay, so how much would be the frictional force? So the frictional force is equal to what? M multiplied by A. Let's take magnitude only. Okay, so it is 2 multiplied by 0.6 meters per second squared. Okay, and this is equal to what? Mu s multiplied by mg. Okay, so this 2 and m gets cancelled out, and you can take the g on the other side. So what do you get? 0.06. Okay, so 0.06 will be the answer. Got it or not? Okay, this will not be mu s. Let's call it mu only, because it is sliding, right? It is 0.06. Sanjay, you got this or there is a doubt? Okay, so next question. A smooth block is released at rest on a 45-degree incline and then slides a distance d. It slides a distance d. The time taken to slide is n times as much to slide on a rough incline, okay, than on a smooth incline. So time taken on rough incline is n times than that of smooth incline. The coefficient of static friction is. Okay, so this is the question. So let's consider this is, sorry, so this is a rough incline, and so this is the block. So what will be the forces acting on it? What will be the acceleration? We had found the acceleration in this case is g sine theta minus mu multiplied by g cos of theta, right? Remember this. If there is friction, okay, it is sliding, the acceleration will be g sine theta minus mu into g cos of theta. So let's call it AR. Okay, and if it is smooth incline, then there is only one force acting on it. That means there will be only one acceleration. And what will be that? It will be g sine theta only. So acceleration on smooth incline. Okay, so acceleration on the smooth incline is equal to g sine theta only. Now suppose it covers distance d on this incline and this incline. The time is different. Okay, and it is given. So distance d can be written as s is equal to ut plus half at square. We have the formula, right? If it begins to slide, initial velocity will be 0, and it has got some acceleration. Okay, different on different roads. Okay, so d is equal to, I can say, half of a multiplied by t square. So for rough incline, let's put it AR, and TR. For smooth incline, it will be equal to half of AS, okay, TS square. So we can equate these two because they are, I mean, the block covers same distance on rough as well as smooth incline. So we can equate these two. So AR times TR square is equal to AS times TS square, and it is given that time taken to slide is n times on the rough incline than the smooth incline. So time on the rough incline is how much? It is n times that of the smooth incline. So this square is equal to as multiplied by ts square. So we can cancel out time on the smooth incline square on both sides. So here it will be n square. So acceleration on rough surface multiplied by n square is equal to acceleration on smooth surface. Okay, so this is what we got, and there we will put the values of acceleration AR and AS. So let's add a page. All right, so I got acceleration on rough surface multiplied by n square is equal to acceleration on smooth surface. So acceleration on rough surface is g sine theta minus mu multiplied by g to cos of theta. okay, multiplied by n square is equal to g sine theta, okay, and it is 45 degrees. So sine theta and cos theta is equal, right? So sine theta and cos theta is equal. So you can take 1 minus mu, because this is 45 degrees. Okay, so g sine theta is also 1 upon root 2. Cos of 45 is also 1 upon root 2. So I will take it outside. So 1 minus mu multiplied by n square is equal to this thing, g sine theta. So g sine theta and g sine theta will get cancelled. Okay, so 1 minus mu multiplied by n square is equal to 1. So take n square on other side. 1 minus mu is equal to 1 upon n square. Then take mu on right hand side, this thing on left hand side. So you get mu equals to 1 minus 1 upon n square, or n square minus 1 upon n square. 1 minus 1 upon n square. This is the answer. Option C. Okay. A block of mass 2 kg is placed on the surface of a trolley of mass 20 kg, which is on smooth surface. The coefficient of friction between the block and the surface of trolley is 0.25. If the horizontal force of 2 Newton acts on the block, the acceleration of system in meters per second square is. Okay, so there is a block kept on a trolley. Okay, so this trolley, I'm drawing like this. Okay, so mass of block is m, is 2 kg. Mass of trolley, let's suppose it is capital M, it's 20 kg. And there is some coefficient of friction, 0.25. And you are exerting horizontal force 2 sorry 2 Newton on the block. Okay, the acceleration of the system is, you are exerting a force on this block only and not on the trolley. So now you have to check whether this exerted force is greater than the limiting value of static frictional force, or if it is less than that. If it is greater, then what will happen? Only this block will move. Okay, because in this exerted force will exceed the frictional force. Okay, but now if it is less than the frictional force, what will happen? Then the friction will hold this block on the trolley. Okay, so block cannot move. That means the block as well as trolley will move. You got this? Yes, no? If it was floor, then nothing will move. But this trolley is also movable, right? The trolley is movable. Okay, so you have to check whether this block will slide on the trolley with if the external force is greater than frictional force, or it is less than frictional force. If it is less than frictional force, then what will happen? Both of them, they will be glued to each other, because external force is less than the frictional force. So got this or not? Okay, so let's check. Okay, so how much is the external force? It is 2 newtons. And how much is coefficient of friction? 0.25. Okay, so coefficient of friction is 0.25. How much will be weight of this? mg. Normal reaction is equal to mg. Okay, so limiting value of frictional force, Fs max, is equal to mu s multiplied by normal reaction. So mu s multiplied by mg. So mu s is 0.25 and n is equal to mg, which is 2 multiplied by 10. So 2 times 10 is 20. 20 multiplied by 0.25 is how much? 5. Right? Or 0.25 times 2 is 0.5, 0.5 times 10 is 5. Okay, so it is 5 Newton. Okay, and external force is how much? External force is 2 Newton only. So not enough to slide this block. Okay, not enough to slide this block. So what will happen? The block and this trolley, both of them will move with some acceleration. Okay, so this external force is equal to total mass of the system, which is m plus capital M multiplied by acceleration. So acceleration is equal to F divided by total mass, which is 22, 2 upon 22. It will be close to 0.1, 0.9, oh sorry, 0.09 will be the answer, right? All right. So this problem is, what is the maximum value of force F such that the block shown in the arrangement does not move? Okay, so the arrow of this force is not like this, it is like this. Okay, so force is acting slanting downwards on this block. So now we have to find out maximum value of this force such that this block does not move. Okay, so what will we do? We'll resolve the force along two components. So one horizontal component which will act like this, so which will try to move the block in horizontal direction towards right. Okay, and one vertical component which will be like this. So the horizontal component of this force, so this angle is 60 degrees. Okay, so since this angle is 60, this will be equal to 60 degrees, and therefore this is f cos of 60, right? The horizontal component is f cos 60, and the vertical component is f sin 60, right? And it is acting vertically downwards. So now, since this block is trying to, this force is trying to move the block towards right, what will be the direction of frictional force? Frictional force will act towards left, right? So frictional force will act towards left, and since the block doesn't move, so frictional force is equal to what? It is Fs cos theta. Okay, Fs cos 60 degrees, right? The two forces are balanced, so block doesn't move. Okay, and we want to find out maximum value of this F. So that means this frictional force will be maximum. It is Fx max. Okay, so this is, so from here I can say that Fs max is equal to what? F cos 60, and we know what is Fs max. It is mu multiplied by normal reaction, so it is F cos 60. This is, let's call it equation 1, and then we have to find out the normal reaction, so that we can find out, okay, using the vertical equilibrium. So block is not moving, or it's not accelerating in vertical direction. That means total vertical forces are balanced. Okay, so what are the other forces? So there is gravitational force which is acting downwards. Okay, so if I look at this block, so there is gravitational force which is acting downwards, mg. This force F sin 60, it is also acting downwards. Okay, so it is also acting downwards, F sin 60, and the normal reaction due to the floor, normal reaction due to this floor will act upwards. So what can we say? That N is equal to, the total upward force is equal to total downward force. Okay, so force is balanced, and that's why I can say N is equal to what? F sin 60 plus mg. So let's substitute that here. So what do we get? Mu times F sin 60 plus mg is equal to F cos of 60. What is cos 60? 1 by 2. Okay, so this will be F by 2. Okay, how much is mu? mu is 1 upon 2 root 3. It is f sine 60. What is sine 60? Root 3 by 2. So it is root 3 upon 2. And what is the mass? Mass is 3. Sorry, root 3. So root 3 multiplied by g is 10. Okay. So this 2 and this 2 gets cancelled. Then we can divide by root 3. So this root 3 and this root 3 will get cancelled. So we have f by 2 plus 10 on left hand side. So f by 2 plus 10 is equal to f. So if we move this f by 2 on right hand side, what do we get? 10 is equal to f minus f by 2. That is f by 2. Okay. And therefore f is equal to 20 newtons. This is the answer. Okay. So this is clear, or is there a question? A wooden block of mass 8 kg slides down an inclined plane of inclination 30 degrees to the horizontal with constant acceleration 0.4 meter per second square. The force of friction between the block and the inclined plane is. So there is a wooden block of mass 8 kg. It slides down an inclined plane. Okay, and inclination is 30 degrees. So this is your inclined plane. This is the wooden block. It slides down and with constant acceleration. So acceleration is given. So let's suppose A is acceleration. Now tell me, what is the acceleration? It is g sine theta minus mu multiplied by g cos theta. Yes, no? Okay, Sanjay, we saw this yesterday. Okay, so you have to remember this. When there is a block, okay, sliding down an inclined plane, what is its acceleration? The g sine theta minus mu multiplied by g cos of theta. We will not derive it again and again. We will just remember this formula. Okay, so this is given, it's 0.4, and then its mass is given. Mass is okay. So inclination is given. That means theta is given. So the force of friction we have to find out. Okay, so from here we'll get value of mu, right? All right, so here we want to find out force of friction, right? So let's multiply this with what? M. Okay, or there is no need to find out mu also. If I multiply this with M, so this is what we'll memorize. Okay, so M into A is equal to mg sine theta minus mu mg cos theta. Okay, so this is, what is this thing? This is force of friction, if you remember. So there are two forces acting on this block, okay, along that inclined plane. So one is what? This component of the gravitational force mg sine theta, and the other force is what? The other force is the frictional force. It is mu multiplied by normal reaction, but it is negative, okay, because it is acting in opposite direction, right? So this is the frictional force. Okay, this is the frictional force, right? So this is minus frictional force, Fs max. So this we can find out directly. Okay, and here mass is given. So it is m times a. Mass is 8 kg multiplied by acceleration is how much? 0.4. Now take this on left hand side. So what do you get? Fs max is equal to mg sine theta. It is 8 multiplied by 10 multiplied by sine of 30 is half, plus this 8 multiplied by 0.4. How much is it? 3.2, right? So plus 3.2. Okay. So it is 40 plus 3.2. If you take this, sorry. There is sign mistake, no? This will be negative. I'm adding this. Okay. So 8 multiplied by 0.4. Okay. It's 3.2. So If I take it on right, it will be negative. So it is 36.8, right? So next problem is a body of mass 100 grams sliding from an inclined plane of inclination 30 degrees. What is the frictional force if mu is equal to 0.7? This is again similar to the last one. Okay, so there is a body of mass 100 grams. It is sliding from an inclined plane and we want to find out the frictional force. So again, we can write mu is given here, not similar to last one. This is easier than that. Okay, so what will be frictional force? Here it is okay, so remember the acceleration formula, g sine theta minus mu into g cos of theta. So out of that, if you multiply this with m, you get this term as a frictional force. So how much is frictional force? It is mu mg cos of theta, right? So mu is 0.7 multiplied by mass is what? 100 grams. It is 0.1 kg multiplied by g is 10 multiplied by cos of theta. Theta is 30. So root 3 by 2. Okay. So 10 times 0.1 is 1. 1 multiplied by 0.7. This is the answer, right? Option D is the answer. All right. Next problem. So a smooth inclined plane is inclined at an angle theta with the horizontal. A body starts from rest and slides down the inclined surface. Then the time taken by the body to reach the bottom. So a body starts from here. We want to find out the time taken by that body, okay, to move till the bottom. So now this is smooth inclined plane. That means there will be no friction. So how much would be the acceleration? Good. G sine theta would be the acceleration. And it slides down this much length. Okay. So now we know the length, that means we know the displacement, right? And it is starting with initial velocity equal to 0. So s is equal to ut plus half at square because we want to find out the time. Okay. So L is equal to ut, u is 0 plus half of at square, that is half of g sine theta multiplied by t square. So from here we will get t. So let's take 2 and g sine theta on the other side. So t square is equal to 2 times L divided by g sine theta, and therefore t will be equal to square root of 2L divided by g sine theta. So is there such an option? Option C? No, but this sine theta is outside and there is no L. Okay, so there is no L. Here there is L, but this is not matching. That means we have to substitute for L. Okay, because other options are in terms of H. Okay, so what is sine theta here? H upon L, and therefore L is equal to H divided by sine theta. Okay, take this L on left hand side, sine theta on right hand side. So L is equal to H divided by sine theta. Substitute that. So substituting that, 2 divided by g sine theta, and L is H upon sine theta. So it will be sine theta square. Okay, for square root is sine theta, you can take it outside. Yeah, it is option C. So 1 upon sine theta multiplied by 2h upon g. This is the answer. Okay, good. A block of wood of 1 kg resting on an inclined plane of angle 30 degree just starts moving down. Okay, again an inclined plane. If the coefficient of friction is 0.2, its velocity after 5 seconds is. Okay, so now we have to find out the velocity. So what is acceleration? G sine theta minus mu multiplied by g cos of theta. Okay, and we want to find out velocity after 5 seconds. So v is equal to u plus at. U is 0, right? It is resting on an inclined plane. That means u is 0. Okay. So a is this and t is equal to 5 seconds. So g sine theta minus mu g cos of theta multiplied by time is 5. Let's substitute values. G you can take out. It is sine theta, which is sine of 30, half minus mu is 0.2 multiplied by cos of 30, root 3 upon 2 multiplied by 5. Okay, so it is 0.5, 10 multiplied by, this is 0.5. So this 0.2 and 2 gets cancelled. I mean 0.1 will be there. Root 3 is 1.73 multiplied by 0.1 is 0.17 minus 0.17 multiplied by 5, and this is 0.50 minus 0.17, so 0.33 multiplied by 10, 3.3 multiplied by 5. Okay, so all our calculations. 3.3 times 5, so 3 5s are 15, 15 plus 1.5, option B. Okay, so it is 16.5. Yeah, option B is the answer. Good. All right. A ball of mass 0.25 kg attached to the end of a string of length 1.96 meter is moving in horizontal circle. The string will break if the tension is more than 25 Newton. Okay. What is the maximum speed with which the ball can be moved? So this is simple, right? So there is a ball of mass, some mass, it is connected to string and it is whirled in a circle. So which thing provides for the centripetal force? It's the tension in the string. Okay. So for maximum speed, the tension will be maximum, right? So mv max square by r is equal to maximum tension. Okay. So v max square is equal to the maximum tension multiplied by r divided by m, and you want the maximum speed, so you take square root of this. Okay, and now substitute the values. So what is maximum tension? 25 multiplied by r is 1.96 divided by mass is 0.25. So this thing divided by this thing gives you 100 multiplied by 1.96 is 196, 14 meters per second, right? This will be the answer. Let's see the next problem. A 500 kg car takes a round turn of radius 500 meters with a velocity of 36 kilometers per hour. The centripetal forces. So first of all, convert the velocity to meters per second. Okay, so v is equal to 36 kilometers per hour. We'll multiply it by 5 by 18. So it is 36 divided by 18 is 2. 2 times 5 is 10. 10 meters per second. Right? And this is straightforward question. Centripetal force is asked, which is mv square upon r. Okay, so FCP equals to mv square divided by r. That is 500 multiplied by 10 square divided by r is how much? 50. Right. Option A. So 500 upon 50 is 10. 10 times 100. 1000. Good. Option A is the answer. A roller coaster is designed such that riders experience weightlessness as they go round the top of the hill whose radius of curvature is 20 meters. The speed of the car at the top of hill is between. We have to find out the speed of the car. So see, why do we feel our weight? Is because of, so let's suppose there is a person. Okay, suppose this is me. So there is gravitational force acting on me, which is in downwards direction. Okay, so I don't feel my weight because of the gravitational force. I feel my weight because of the normal reaction exerted by this floor. Okay, so this floor exerts an upwards normal reaction on me, and this is the reason why I feel my weight. Okay, so we feel the weight because of what? The normal reaction, not because of the gravitational force. Actually, the normal reaction is also because of gravitational force. Okay, so if gravitational force was not were not present, then the normal reaction would be zero. So in turn, it is because of gravitational force only. But how do we feel it? It's because of the normal reaction. Got this? Yes, no? So what is our weight? It's not the gravitational force. It is equal to normal reaction. So now, see, in this roller coaster, when the rider is on the top of the hill, okay, the rider feels weightless. So why so? It's because, see, there will be some normal reaction. If he is feeling weightless, that means normal reaction must be equal to 0. So his weight acts vertically downwards, it's mg, and now he is taking a turn like this. Okay, I mean he is moving in a vertical circle. So there must be some centripetal force. Okay, there must be some centripetal force, FCP, which is acting downwards. So what provides for this centripetal force? So it's very easy. Here, FCP is downwards. Okay, so it is net downward force minus net upward force. So it is mg minus the normal reaction. Okay, and if sorry, and if the person feels weightless, that means n is equal to 0. So FCP is mv square divided by r. It's equal to mg. So m and m gets cancelled out. V square equals to rg. That means v equals to square root of v equals to square root of rg. And what is r? It's 20. So 20 times 10, 200. So square root of 200, 14. Okay, so 14 and 15, somewhere between 14 and 15 meters per second. This is the answer. Is this clear? A gramophone record is revolving with angular velocity omega. A coin is placed at a distance r from the center of the record. The static coefficient of friction is mu. The coin will revolve with the record if. Alright. So gramophone. Do you know gramophone? So nowadays you can either see it in movies or in museums. Okay, this is old thing. Alright. So there is a disc. Okay. And you keep you keep a coin on that disc. Disc is rotating. Along with the disc, coin is also revolving. Okay, so which is the force which is providing for the centripetal force? So here the frictional force provides for the centripetal force. So now the question is, the coin will revolve with the record if. So now there is some angular velocity omega. So now centripetal force required for the motion must be less than the maximum value of friction. Then only it will revolve, otherwise it will skid. Okay, so we can say the FCP required is less than or equal to Fs max. Okay. So what is FCP? So now answers are given in terms of omega. So we will use the formula in terms of omega. So mr omega square, and what is Fs max? It is mu s multiplied by normal reaction, and because this is horizontal surface, normal reaction is equal to mg. Okay, you can cancel out m and m, so you get r omega square is equal to mu s multiplied by g, and you want r, so it will be less than or equal to mu s times g upon omega square. So answer is option C. Is this clear? A car of mass m moving on a level circular track of radius r. If mu s represents the static friction between the road and tires of the car, the maximum speed of car in circular motion is given by. This is very straightforward, very simple. What's the answer? It's the option D. Good. Okay. So they should ask this type of questions. We have found this. The maximum safety speed on a horizontal curved road is square root of mu rg. Okay, so that's what it is. Right. Next question. A car of mass 1000 kg negotiates a banked curve of radius 90 meters on a frictionless road. If banking angle is 45 degrees, the speed of car is. Very straightforward. V is equal to square root of Rg tan theta. Okay, if friction is 0. So let's put the values. What is R? It's 90. G is 10. Tan of 45 is 1. So it is square root of 900. 30 meters per second. Option B. Okay. Next question. A car is moving in circular horizontal track of radius 10 meters with a constant speed 10 meters per second. A bob is suspended from the roof of the car by a light wire of length 1 meter. The angle made by the wire with the vertical is. Okay, so this is some question till now, right? So there is a car and there is a bob suspended in that car. Okay, so let's suppose this is the car and it makes some angle, right? The string makes some angle. So why does it make that angle? It's because the car is moving in circular motion, so string will get aligned in such a way that horizontal component of string will provide for the centripetal force to this bob. Okay, so now you can resolve this tension in the string along two components. So this angle is theta. Let's suppose this angle is theta with the vertical. Okay, and we want to find the angle with the vertical only. So this is theta. So this is t. So this component will be t cos theta, and this component will be t sin theta. So for this bob, the t cos theta balances the weight, and t sin theta provides the centripetal force. So t sin theta equals to mv square upon r, and t cos theta equals to mg. If you divide these two equations, what happens? Gets cancelled. Okay, tt gets cancelled. You get tan theta equals to v square upon rg, right? So theta is tan inverse of that, v square upon rg. Put the values. What is v? 10 meters per second. 10 square. What is r? Okay, we want to find tan inverse of whatever it is. What is R? R is 10, G is 10. So 100 upon 100, 1. So which is that angle whose tan is 1? 45 degrees. So what's the answer? It is in terms of pi. Option C. Okay, it is pi by 4. Pi is 180. 180 upon 4 is 45 degrees. So this is clear. Yes, no? Okay, Tamil Selvi. Okay, good. Let's move on to the next problem. Two stones of masses m and 2m are whirled in horizontal circles. The heavier one in radius r by 2 and lighter one in radius r. Okay, the tangential speed of lighter stone is n times that of the value of heavier stone when they experience same centripetal forces. Okay, so same centripetal forces, right? So FCP for first one is equal to FCP for second one. Okay, so that is, let's call it m1 v1 square upon r1 is equal to m2 v2 square upon r2. So suppose this is the lighter one, this is the heavier one. Okay, so then now m2 is 2 times m1, v2 is given, okay, not v2. So speed of the lighter one is n times the speed of heavier one. So this is n times v2. Okay, n times v2, and we have square of that. It is v2 square m1 upon r1, and heavier one has radius r1 by 2. Okay, so now everything gets cancelled out. So m1 and this m1 gets cancelled, r1, this r1 gets cancelled, v2 and this v2 gets cancelled. I mean v2 square gets cancelled. So you have n square is equal to this 2 and 2 from denominator, take it to numerator. N square is 4, so n is equal to 2. Okay, very simple. A car is negotiating a curved road of radius r. The road is banked at an angle theta. The coefficient of friction between the tires of car and the road is, tell me the maximum safety speed, the maximum safe velocity. Option D, right? Option D. Okay, NEET 2016. Next question. One end of a string of length L is connected to particle of mass m and other end is connected to small peg on smooth horizontal table. If the particle moves in a circle with speed v, the net force on the particle will be. Okay, so you got the question. There is one end of string of length L is connected to particle of mass m and the other end is connected to a peg. Okay, like this. And it moves in horizontal circle. It moves in horizontal circle, right? With speed v. The net force on the particle is. What will be net force on the particle? So there will be tension in the string acting towards the center. So tell me. It is resting on horizontal table. So there is mg acting downwards. Let's use other color. Mg acting downwards, normal reaction due to table upwards. Okay, they get cancelled out. What's the net force? It's tension only, nothing else is there. right? What is the answer? Tension in the string only. You got this? Yes, no? This is clear, no? Everybody? Okay. Next question. A block of mass 10 kg is in contact against the inner wall of hollow cylindrical drum of radius 1 meter. The coefficient of friction between the block and the inner wall of the cylinder is 0.1. Okay. The minimum angular velocity needed for the cylinder keep the block stationary when cylinder is vertical and rotating about the axis. So see, there is a cylinder there is a cylinder like this. It is rotating about an axis passing through the center, and there is a block of mass m, okay, which is resting against the wall of the cylinder. So have you seen something like this? Have you seen death of well? It is called as maut ka kuआ in Hindi. I don't know what is it called in Tamil. Death of well in fair or in a circus, maybe not. It's okay. So this is like that. Okay, there is a hollow cylinder and this block is resting against the wall. Okay, so now this cylinder is rotating. So due to this rotation, what will happen? This block is providing some normal reaction. Okay, some normal reaction which is providing for the centripetal force. Okay, what are other forces acting on it? One will be the gravitational force acting downwards, right? One will be the gravitational force acting downwards, and since it doesn't fall, there would be frictional force acting upwards, right? Okay, so this frictional force is equal to mu multiplied by normal reaction, and since it doesn't fall, frictional force must be equal to what? The gravitational force. Okay, therefore it doesn't fall. Yes, no? Okay, and now with what speed it must rotate? Okay, such that the frictional force is equal to gravitational force. That's what we have to find. So here the normal reaction provides for the centripetal force. Okay, that means normal reaction is equal to what? Mv square upon r. So mu times normal reaction is equal to mv square upon r because it is providing for the centripetal force. Okay, this is equal to m times g. So m and m gets cancelled out and you get v square is equal to what? Rg divided by mu. Let's put the values. So v is equal to square root of that. So tell me what will be the answer. Radius is 1, g is 10, mu is 0.1. So square root of 100. So v is equal to 10. Right? And you want angular velocity. So v is equal to 10 and v is r omega. Right? V is equal to r times omega. How much is r? R is 1. Okay, so v equals to 10. It is r times omega, which is 10. So r is 1. That means omega is equal to what? 10 radians per second. Okay. Have you understood this, everybody? So today we are going to solve some more problems based upon the free body diagrams. Let us see this problem. So 4 blocks of same mass connected by strings are pulled by a force F on a smooth horizontal surface as shown in the figure. The tension T1, T2, T3 will be. So this is very simple problem. Can you tell me what will be the tension? Alright, so this is a smooth horizontal surface. Okay, that means there is no friction, and if you can see this, there is this force F. Okay, it is acting on these 4 masses. So what can I say? The net force is equal to what? 4 masses, m plus m plus m plus m. Okay, 4m times, this is the total mass multiplied by acceleration. Okay, now you can start drawing the free body diagrams. So if I talk about this last mass, okay, so this mass is m and acceleration is a. So the tension acting on this mass is T3, right? It is T3. So what can I say? T3 is equal to m multiplied by a. So how much is it in comparison with this force? Compare it with this force F. Force is equal to 4m times a. T3 equals to m times a. So force is 4 times compared to T3. So T3 equals to F by 4, I can say. Similarly, if you take this second mass, okay, so on this second mass, T2 is acting on this side, T3 is acting on this side. Okay, so this is T3, this is T2. All right, so T2, I can say force acting on this one also. It is m into a, because all of the masses will have same acceleration. Okay, so force acting on this one is also m times a. So m times a is equal to what? The force in or the tension in direction of force minus this tension. Okay, so it is T2 minus T3. So how much is it? So how much will be T2? Take T3 on other side. So you get T2 equals to MA. Okay, you get T2 equals to MA plus T3. That is 2 times MA. Okay, and in comparison with force, how much is it? It is F by 2, right? And similarly, you can find out T1. So for this mass, okay, or you can take this mass or this mass to find out T1, right? So if you take this mass, the force acting on it on towards right is T2, force towards left is T1. So how much will be T1 minus T2? So T1 minus T2 is also m times a. Okay, so take T2 on left hand side. So you get T1 equals to what? T2 plus ma, that is 3 ma, and that's equal to what? Ma is equal to F by 4, right? So this is equal to 3 times F by 4. This is simple. Okay, so what is the answer? T1 is 3 times F by 4, T2 is F by 2, T3 is F by 4. So option C is the answer, right? Option C is the answer. This is very simple problem. See, there are two masses, 10 kg and 20 kg respectively. They are connected by a massless spring as shown in this figure. Okay, a force of 200 newtons acts on 20 kg mass. At the instant shown in the figure, 10 kg mass has acceleration of 12 meter per second square. The value of acceleration of 20 kg mass is. This is the question. So we can draw free body diagram. So if we think about 10 kg mass, okay, what is the force acting on it? Only F, right? And its acceleration is given. Okay, its acceleration is given is 12 meter per second squared. So how much would be F? It is this mass multiplied by acceleration. Okay. So it is 10 multiplied by 12. So 120 newtons. And if you think about the second mass, 20 kg mass, what are the forces? One is the spring force acting towards left. Okay. And one is this 200 Newton force. Right. The spring force will be equal and opposite. Okay. So for 20 kg mass, it will act towards left. And we have found it out. It's 120 newtons. So how much is the net force acting on this 20 kg mass? Let's suppose its acceleration is A. So m into A is equal to this 200 Newton minus F. Okay, 200 minus F is 120 and mass is how much? It is 20. So 20 times A is 200 minus 120, which is 80. Right. So A is equal to 80 by 20. So 4 meters per second square. Option A. Right. This is simple. The next problem is, now there is some complexity. Okay, little bit complex because there is friction. The coefficient of static friction mu s between the block of mass 2 kg and the table as shown in the figure is 0.2. So coefficient of friction is given. What would be the maximum mass value of block B? What would be the maximum mass of B so that two blocks do not move? Okay, they are not moving. The string and the pulley are assumed to be smooth and massless. The string and pulley, they are massless. Okay, so this is again a simple question, right? So if you think about this block B, it's not moving. That means what are the forces acting on it? One is the tension in the string and other force is what? Its weight downwards. Okay, so if it is not moving at all, that means this tension acting upwards is equal to mg, right? So you can say T is equal to mg. Okay, and how much is its mass? That we have to find out, right? Okay, what is the mass of block B? That we have to find out. So it is, let's suppose, m. So T is equal to mg. And for this block A, now there is tension T acting towards right, and there would be another force. So if it tends to slide on this floor, there will be the frictional force acting towards left, right? And how much would be the friction? So friction is equal to mu multiplied by normal reaction. Okay, and if this one doesn't move, then this friction must be equal to the tension, and tension we have found it is equal to what? Mg. Okay, so this is equal to tension, which is equal to what? Mg. Now mu multiplied by normal reaction. So what is normal reaction? Because this is horizontal surface, the normal reaction is equal to weight. Okay, so how much is weight? So its mass is 2 kg. So weight would be how much? 2 multiplied by 10, and it is equal to mg. Right? It is equal to mg. Okay, you can cancel out this 10 and g, or you can substitute g equals to 10 and you can cancel it out. So this gets cancelled out. So m is equal to mu times 2. So how much is mu? How much is mu? 0.2. Right. So it is 2 times 0.2. 0.4. 0.4 is the answer. Option D. Okay, this is clear. So a system consists of three masses m1, m2 and m3 connected by a string passing over a pulley P. The mass m1 hangs freely and m2 and m3 are on rough horizontal table. Okay, so these are on rough horizontal table. The coefficient of friction is mu. The pulley is frictionless, so pulleys are frictionless and of negligible mass. the downward acceleration of mass m1 is. So now there is some acceleration. Okay, so that we have to find out. All right. So we can bundle up these masses m2 and m3 because we don't care what happens in between these two masses, right? So m2 and m3 we are bundling up, and there is some tension in the string T acting towards left. So how much will be the tension in the string? That we don't know it, we have to find it out. Okay, so there is some tension in the string, and since this is a rough surface, there would be some frictional force acting towards right. Okay, so suppose there is some frictional force F acting towards right. So how much would be their acceleration? So we can say the total mass. Total mass is m2 plus m3. Right, this is the total mass. m2 plus m3 multiplied by A. This is the net force. Net force is towards left. So it is total force towards left minus total force towards right. Okay, so it is equal to what? T minus F, the frictional force. And how much would be the frictional force? Mu multiplied by, yeah, but what is M? M is m2 plus m3. Right, friction is acting on both of them. So, okay, so total mass is m2 plus m3. Okay, so it is m2 plus m3 multiplied by A is equal to T minus mu multiplied by mg. So m is m2 plus m3 multiplied by we have g. So let's call this equation number 1, and then let's draw free body diagram for m1. So what are the forces acting on m1? There is gravitational force m1 times g, and there is tension in the string, which will be equal to this tension. Okay, so here what can we say? That it accelerates downwards, and that acceleration will be same as that of this acceleration. Okay, because the whole system is connected. So acceleration is A, so the net force will be downwards, and how much would be that? So net force is m1 times A, it's equal to m1 into g minus tension in the string. So this is your equation number 2. Okay, and then you add 1 and 2. So what do you get? The tension will get cancelled out, right? Tension will get cancelled out, and you get m1 into A plus m2 plus m3 times A is equal to, on right hand side you have m1 times g and minus, okay, m1 times g minus mu times m2 plus m3 times g. Okay, and all the masses are equal, so you can substitute that also. So m2 plus m3 will be what? 2m. Okay, this is equal to m. Okay, so this is 3m. So 3m times A is equal to m times g. So you can take m common also. M times g minus mu times 2 times m. m2 plus m3 is 2 times m multiplied by g. You can cancel out m from everywhere, and then you want to find out the acceleration. So take 3 on the other side. So it is g minus mu times 2g divided by 3. Or you can take g common. So what do you get? Which option? If you take g common, you get 1 minus 2 mu. Option C, right? Okay, so this one also was simple problem, right? All right, so let's move on to the next one. Okay, a block A of mass m1 rests on horizontal table. A light string connected to it passes over frictionless pulley at the edge of table, and from its other end another block B of mass m2 is suspended. Okay, so there is block of mass m1. It rests on horizontal table. Connected to it is a string which passes over this pulley, and from that string another mass is connected, which is m2. It is suspended, right? It's suspended. The coefficient of kinetic friction between the block and the table is mu k. Okay, so mu is suppose the coefficient of kinetic friction when the block A is sliding on the table, the tension in the string is. So this is exactly similar to the last problem, but in this case we want to find out the tension. Okay, so let's find out tension. So let's draw free body diagram of M2. So for M2, the gravitational force is acting downwards. So it is M2 times G. Tension is acting upwards, T. Okay, so net force will be M2 times A is equal to total downward force M2 times G minus the tension. Okay, similarly, let's call it 1 second. So consider mass M1 and there is some friction acting on this mass M1. So frictional force acts towards left F and towards right is the tension in the string. Okay, tension in the string. So the net force is M1 times A. You can say M1 times A is equal to tension in the string. Okay, tension in the string minus what? The frictional force. And how much will be frictional force? Mu multiplied by the normal reaction. And how much will be the normal reaction? It's equal to its weight. Okay, so mu multiplied by m1 times g. This is equation number 2. So if we add these two, what do we get? Tension gets cancelled out, right? Tension gets cancelled out. So we get m1 plus m2 times a on left hand side. It's equal to what? M2 times g minus mu times m1 into g. And if you move this m1 plus m2 times a towards right, you get the acceleration. Okay, so you get the acceleration a is equal to m2 times g minus mu into m1 times g divided by m1 plus m2, and substitute that in first equation or second equation to find out the acceleration. So let's put in the first equation. Okay, sorry, to find out tension. So T equals to, what is tension? This m2 into g minus m2 times a. Okay, if we substitute that, what do we get? What do we get? Acceleration we have to substitute. So tension is equal to m2 times g minus m2 times a, and a is m2 times g, m2 times g minus mu times m1 times g divided by m1 plus m2. Okay, so let's multiply and divide this term with m1 plus m2. So it is m1 m2 times g plus m2 square times g, and everything divided by m1 plus m2, and let's multiply this one with m2. So minus m2 square g, and this minus minus becomes plus. So it is mu m1 m2 g. Slightly lengthy question. This thing gets cancelled out. M1 M2 you can take common. So M1 M2, okay, 1 plus mu times g divided by M1 plus M2. I think this should be the answer. So it is M1 M2 1 plus mu g divided by option A, right? If plus minus everything is correct, option A is the answer. In the given figure, the pulley is assumed massless and frictionless. This pulley is massless and frictionless. If the frictional force on the object M is F, there is some frictional force, then its acceleration in terms of force F will be equal to. Okay, so for this kind of problem, remember there is pulley, okay, and this end of the string is connected to rigid support. Okay, there is another end which is connected to mass. So now there is tension acting on both the sides. So if you think about the pulley, there is tension in the string T and T, right? And there is force acting towards right. Okay, so now pulley is massless. Pulley doesn't have a mass. So you can say mass times acceleration is equal to what? 0. Okay, so that 0 is equal to, the net force is 0 because mass is 0. Okay, so it's equal to F minus 2T. Okay, F minus this tension plus this tension, 2T, and therefore you get 2T equals to F or T equals to F by 2. You got this? Yes, no? All right. So for question like this, please remember you have to solve, you have to apply, I mean, you have to draw free body diagram of pulley first. Okay, or intuitively you can say F is equal to what? 2 times T, because there are two strings pulling on this pulley towards left and there is this force acting towards right. Okay, so F will be equal to 2T and T will be equal to what? F by 2. Okay, directly you can say. And then you have this mass. What are the forces acting on this mass? So there is one force due to the string, tension in the string, and it's given that there is some friction, small f. Okay, so friction is small f, right, towards left. So what is the net force? T minus F is the net force. Okay, so M times A is equal to T minus F, not capital F, it's small f, and therefore acceleration is T minus F divided by M. And what is T? We have found it out, it's F by 2. So let's substitute that. It is F by 2 minus F divided by M. Is there such an option? Yes. Option B is the answer. Okay. This question is clear? All right. Let's move on to this next question. A block of mass M is in contact with the cart C. There is this cart C and this mass is in contact with this. Okay, this block is in contact with the cart. As shown in the figure, the coefficient of static friction between the block and the cart is mu. Okay, the acceleration alpha of the cart that will prevent the block from falling satisfies. Okay, so that mass is just kept like this, right? The mass is just kept like this and the cart accelerates like this, and because of that acceleration the mass doesn't fall. So how much should be that acceleration? Okay, so there are two ways of solving this problem. One is considering the non-inertial frame of reference and another one is considering the inertial frame of reference. Okay, so we'll use inertial frame of reference first and at the end I will tell you about the non-inertial frame of reference. Okay, our observer is outside. Okay, so observer is, let's suppose, here looking towards the system. So for this observer, what is the force acting on this mass? It's the normal reaction, right? And because of this normal reaction, what happens? This mass also gets accelerated with the same acceleration as that of the cart. Yes, no? Okay, so therefore I can say the normal reaction which is acting towards right like this, it is equal to what? This mass multiplied by the acceleration alpha. Okay, and if the mass doesn't fall, that means the weight is balanced by the frictional force. So frictional force is upwards. Okay, so how much will be the frictional force? It's mu times the normal reaction. Okay, so if it doesn't fall, mu times normal reaction, I can say mg is equal to mu times the normal reaction. Okay, right, weight is balanced by the frictional force. And how much is normal reaction? It is m times alpha. So put that, so mu multiplied by m times alpha is equal to mg. Okay, right? So here, if it doesn't fall, then maximum friction should be greater than or equal to, right, mg. Okay, so mu times n is greater than or equal to mg, we can say. And now we will substitute n equals to what? M alpha. So it is m alpha is greater than or equal to mg, and then this m gets cancelled out. So you want alpha, no? So alpha is equal to greater than or equal to what? G divided by mu. Option C is the answer. So is it clear? So let's see this next question. A block of mass m is placed on a smooth inclined wedge. So this is that smooth inclined wedge, and this block is kept here. Okay, ABC of inclination theta. Okay, inclination is theta, as shown in the figure. The wedge is given an acceleration a towards the right. Okay, it is given some acceleration towards right. The relation between a and theta for the block to remain stationary on the wedge. So how much should be that acceleration? Okay, we have to find out acceleration such that this block remains stationary. This is the question. Okay, so once again, we'll consider our observer is looking from outside. Okay, so our observer is inertial. For this inertial observer, now what are the forces acting on this block? You solved it? G divided by A equals to, no. Wait. I will tell you. See, this block is there. It is stationary. It's not moving. See, now there would be the normal reaction acting on this block, which is in this direction. Okay, and the system is accelerating like this towards right. And there is the weight of this block acting downwards, mg. These are the two forces, only two forces. So you can resolve the normal reaction along two perpendicular components. So if this angle is theta, this angle here will be theta, right? So this one will be 90 minus theta. Okay, so therefore this component is equal to what? Because this is 90 minus theta, it is n sine theta, and this component will be n cos theta. So do you understand this? Okay, you understood the resolution? See, this angle is theta, so this angle will be theta. Okay, this angle is 90 degrees, so subtract theta from 90. So this one will be what? 90 minus theta, and this one will be theta, you can say. Okay, so if this is theta, this is the cos component, this is sine component, right? Okay, so now this mass is also in acceleration because wedge is in acceleration, so this block is also in acceleration, okay, towards right. So here you can say that mg, the weight of this block, it is balanced by the vertical component of normal reaction. Okay, and the block is in acceleration, so that Acceleration is provided by the horizontal component of normal reaction. Got this? Yes, no? Okay, so I can say n cos theta is equal to mg, and n sin theta is equal to what? The horizontal force acting on this block due to the wedge. Wedge is moving like this. Okay, so wedge is moving like this. It is exerting some horizontal force on the block. It is m times the acceleration a. So it is provided by what? Horizontal component of normal reaction. And now you can divide first by second or second by first. So n and n will get cancelled out. Okay, so if I divide second by first, I will get tan theta equals to what? Ma divided by mg, that is a divided by g, and therefore a is equal to g tan theta. So g tan theta, option D is the answer. Understood? Okay, so a block of mass m is placed on smooth wedge of inclination theta. Sorry, a block of mass m is placed on a smooth wedge of inclination theta. The whole system is accelerated horizontally so that block does not flip on the wedge. So this is similar to the last problem. Okay, the force exerted by wedge on the block will be. So in earlier case, what was asked? The acceleration was asked. In this case, the force exerted by wedge on the block is asked. Okay, so can you tell me, looking at this problem, what would be the force exerted by wedge on the block? This problem is similar. See, there is this wedge and this block. Okay, so force exerted by wedge on the block is equal to the normal reaction. It is equal to what? The normal reaction. So how much is that? That we have to find out. Okay, so there is another force which is acting downwards. Mg is acting downwards. This angle is theta, and the system is given acceleration a. Okay, so now what we can say here is we can resolve n along two components just like the previous problem. So this component will be n cos theta because this angle is theta. So this angle will be theta. This is 90 minus theta. So this will be theta. So this component is n cos theta. This other component is sin theta. Okay. And n cos theta is equal to mg. Right. So the options are given in terms of mg. So I can say n cos theta is equal to mg, and therefore n is equal to what? Mg divided by cos theta. Okay, it is mg divided by cos theta. Option D is the answer. So see, a mass m is placed on very smooth wedge resting on surface without friction. Once the mass is released, the acceleration to be given to the wedge so that m remains at rest is a, where? Okay, so m is released, m is kept there. Okay, and you are moving the wedge such that m doesn't fall. So how much acceleration should be given? So we had solved this. How much acceleration should be given? A is equal to g tan theta, right? So which option is correct? G tan theta is here, here also. So should it be applied towards left or towards right? Right or left? Left. Okay. If you apply it towards right, yeah, Sanjay. if you apply it towards right, what will happen? The block will slide even faster. Okay, it is already falling down, and you are taking this wedge away actually, so it will slide even faster. Okay, you have to exert it towards left such that there will be a normal reaction, right? If you pull it towards left, then only there will be a normal reaction. Got it? Okay, so answer is option A. It has to be applied towards left. Okay, such that it provides some normal reaction. Okay, if you move it towards left with some acceleration, and the horizontal component of that normal reaction provides the acceleration. Okay, provides that acceleration. So then let's look at this problem. A heavy uniform chain lies on horizontal top of table. If the coefficient of friction between the chain and the table is 0.25, then the maximum percentage of length of the chain that can hang over one edge of the table is. So there is a table. This problem is not asked in the NEET exam, but it can be asked. It has been asked in many medical and engineering exams. Okay, other exams. So there is a chain like this. Okay, so I will just fast forward the drawing process. This is the chain. So its one end is hanging like this. Okay, so what's given? A heavy uniform chain lies on horizontal top of table. It lies on the horizontal top of table. If coefficient of friction it's given, then the maximum percentage of length of chain that can hang over one end. Okay, that we have to find out. So let's suppose this length is L, and the total length of this chain is equal to capital L, right? So total length is capital L, and the length that hangs is small l. So how much would be this length? Capital L minus small l. Okay, so this length is this much length. I can say it is capital L minus small l, and we'll consider that the mass is uniformly distributed over the length of this chain. Mass is uniformly distributed over the total length of the chain. So the mass of this part and this part, they are in proportion to their length. Okay, so now let's talk about the part that is hanging. Let's talk about, okay, this part which is hanging, right? So what are, okay, this part which is hanging. So what are the forces acting on this part? I can say there is tension along the chain which is acting upwards, and there is the gravitational force which is acting downwards. So how much would be the gravitational force? It will be equal to mass of this part multiplied by g. Okay, and how much would be mass of this part? If total mass is capital M, this total mass, okay, then I can say mass of this part is equal to what? The fraction of length multiplied by this mass. Okay, so what is fraction of length? So I can say it is L upon capital L. Okay, this can be 50%, right? This can be 25%, this can be whatever. We have to find out that percent. Okay, so L upon capital L. This length divided by the total length multiplied by the mass. This much would be the mass of this fraction. Sorry, this much would be the mass of this section. Yes, no? And multiplied by g is its weight. Okay, and if it doesn't fall, that means the tension is equal to what? Tension is equal to this, its weight. Okay, L upon L is equal to, sorry, multiplied by mg. So T is equal to sorry, So T is equal to L upon L multiplied by mg. If it doesn't fall, right? And what about this? What about this portion? So for this portion, what you can say is there is tension acting towards right and there is the frictional force acting towards left. Okay, frictional force is acting towards left. So if it doesn't slide, that means the tension is equal to frictional force. Okay, so T is equal to what? Frictional force. And what will be frictional force? Mu multiplied by the normal reaction. And what will be normal reaction? It's equal to weight of this part. And what is weight? It is its mass multiplied by g. And how much would be mass? So fractional length multiplied by the total mass. Okay, so length of this part upon the total length multiplied by capital M. So capital L minus small l is length of this part divided by total length multiplied by capital M. This much is the mass. You got this? So tension is equal to mu times mg. And what is mass of this part? Just like we found mass of this part, okay, it's fractional length, okay, multiplied by the total mass. So fractional length of this part is total length minus this length. Okay, not fractional length. Length of this part is total length minus length of this part. You got this? Yes, no? Okay, so then now weight of this part is equal to tension and tension is equal to this frictional force. So this is your equation 1, this is equation 2, and you can equate them. So you get L upon capital M, L multiplied by mg is equal to mu multiplied by L minus small l upon L multiplied by mg. And we can see some cancellations here. L gets cancelled, mg gets cancelled. So we get L is equal to small l is equal to mu multiplied by capital L minus small l. Okay. So I will just erase this part, or let's keep it here. Okay. So we have small l is equal to mu multiplied by capital L minus L. So small l is equal to mu times capital L minus mu times small l. Okay, how much is mu? 0.25. It is 0.25 multiplied by L minus 0.25 multiplied by small l. Take that 0.25 towards left, 0.25 L. So you get 1.25 L because this is 1 L and that's 0.25 L. 1.25 L is equal to 0.25 capital L. Okay, so you want the fractional length that is hanging. So small l upon capital L is equal to 0.25 divided by 1.25, or you can say it is 1 by 5. Okay, so 1 by 5, 1/5. And if you multiply this with 100, what do you get? L upon L multiplied by 100 because you want percentage. So it will be 1 by 5 times 100, 20%. Okay, now what we'll do is I will tell you another way to solve problems, that is the non-inertial frame of reference. Okay, so we'll take similar problems, same problems that we took earlier. Okay, so earlier we solved this problem and this problem using which frame of reference? Inertial frame of reference. Now we are going to use non-inertial frame of reference and you will see you will get the same answer. All right, so see what happens in non-inertial frame of reference. So for an example, you are standing in a bus, okay, and bus suddenly accelerates, bus accelerates. Let's suppose it accelerates in this direction. What will happen? You tend to fall down like this. Okay, so if bus is accelerating towards right, you tend to fall towards left. Can you explain why are you falling? No. So you say that there is some fictitious force, some pseudo force acting on you. Okay, so it means there is no force acting, but to explain your acceleration towards left, when bus is accelerating towards right, you tend to fall. If bus is moving toward in forward direction, you tend to fall in backward direction like this. Okay, so you can't explain it, this motion, using any real force. Okay, you can give justification, but there is no real force acting on you in this direction. So what do you say? You will feel like somebody is pulling you. Okay, so you say there is a pseudo force. There is a pseudo force acting on you. So if you apply the concept of pseudo force, okay, some ghost is pulling you, then you can explain this motion, right? Another example, suppose you are sitting in a car and car takes a turn towards left. Okay, car is taking turn towards left. You tend to, okay, what happens? You tend to move towards right like this. Yes, no? You tend to fall on the window which is towards right. So this motion also you cannot explain. Okay, this acceleration you cannot explain using any real force. So you can say there is a pseudo force acting on you which is towards right. Another example, in circular motion, what happens? The vehicles, they tend to slide towards outwards the circle. Okay, outwards of the circle. So if suppose there is a vehicle like this, it's moving on the circular road, it tends to move, tends to slide like this. If there is no friction to keep it on this road surface, it will slide away from the center. Okay, so we say there is a centrifugal force, there is a pseudo force acting on it. Okay, which in this case we call it as centrifugal force, because this sliding cannot be explained using a real force. So we say a centrifugal force is acting. Another example, which is again for circular motion, that suppose there is a merry-go-round. Okay, there is a fair, and have you seen merry-go-round? Looks like this. I mean, there is a circle. Okay, and there are some rods. Some animals are connected to, maybe the horses, etc. They are connected to that. Okay, so there are n number of them, and this thing, okay, this toy will rotate and you sit on this horse. What happens? So as it rotates faster and faster, this horse and the person sitting on it, it moves away from the center. So it's like somebody is pulling it. Okay, somebody is pulling that person away from the center, but you cannot explain it using what? Any real force. So you say that there is some centrifugal force acting on that person, right? So that is the pseudo force. Okay, so why is it happening? Why are these people, this person or this car or person sitting in this car, or when car is taking turn towards left, then person sitting there, let's suppose you cannot explain it, okay, that motion using any real force? It's because these are all non-inertial observers. These, all of these observers are in acceleration. This motion is accelerated motion, and the Newton's laws, they are applicable for inertial observers. Okay, So the Newton's laws are applicable to inertial observers. If non-inertial observer wants to explain the motion, he has to take the help of pseudo force. And what is the direction of that pseudo force? So you see here, in case of bus is accelerating towards right. Okay, this person gets accelerated towards left. That means pseudo force is opposite to the acceleration. And how much is its magnitude? Magnitude is equal to mass of the person multiplied by this acceleration. Okay, so to explain this motion or this motion, we'll take an example, sorry, we'll take the help of pseudo force. So how much is the magnitude of pseudo force? It is mass of the person multiplied by this acceleration, and it acts in opposite direction of this acceleration. Okay, let's proceed. Okay, so now let's suppose the observer is here. Okay, so observer is also in acceleration. Earlier we considered observer was here, standing on the road and watching these two bodies. Now let's suppose the observer is riding along with the body. Okay, so observer is also in acceleration. So this system is accelerating towards right. For this observer now, okay, so let's suppose observer is on this block. So for this observer now, there will be a pseudo force acting on him. And what will be the direction of pseudo force? It is opposite to the acceleration we have studied, right? So what will be direction of the pseudo force? The pseudo force acts towards left, because observer is accelerating towards right. The pseudo force acts towards left. Okay, so I will call it FP, P for pseudo, right? And now let's draw all the real forces acting on that person or the block. So what are the real forces? The real forces, the normal reaction due to this cart. Okay, it acts like this. Sorry. And the gravitational force acts downwards, and the frictional force acts upwards. Okay, so this observer says, I am not accelerating, I am at rest. Okay, I am not accelerating towards right, the world is accelerating towards left. That's the perception of the observer who is riding along with the block. Got it? Yes, no? So frictional force is upwards. Okay, so I'm sorry. So for this observer, what did we consider earlier? That the normal reaction provides a force. Okay, normal reaction, sorry. So for this observer, what did we consider? The normal reaction is towards right, and it's because of that normal reaction that this block also gets accelerated along with the cart. But for the observer who is riding along with the block, so for him, he is at rest, he is not moving, okay, but there is a pseudo force acting on him. Okay, so it will be towards left. So this is the direction of pseudo force. And what is normal reaction doing? Because the observer is at rest, the normal reaction is balancing that pseudo force. Got it? Normal reaction is, so for that observer, I would say for observer riding along M, normal reaction balances pseudo force. Okay, so N is equal to the pseudo force. And how much is magnitude of pseudo force? We have studied it. It is mass of the observer multiplied by this acceleration. So N is equal to M times alpha, right? And then if the block doesn't fall down, then frictional force is equal to what? Mg. Okay, so F, which is F has to be greater than or equal to mg, right? So I will move all of this upwards. Okay, so what is F? It is mu multiplied by normal reaction. And what is normal reaction? It is m times alpha. So mu m alpha is greater than or equal to mg. Okay, gets cancelled. So you get alpha greater than or equal to g divided by mu. So you get the same answer, option C, only change in perception. So earlier we considered this observer who is an inertial observer. Now we considered an observer who is riding along with this mass. Okay, so observer is in acceleration, and that's why for this observer we considered a force which is in opposite direction to the acceleration, called the pseudo force. So is this thing clear? Is the problem clear? Okay, so this is how we solve problems using non-inertial frame of reference. So earlier in this problem also, so what is this problem? A block of mass m is kept on the smooth inclined plane, and the incline is accelerating like this. Okay, so earlier we considered an observer who is inertial. Now we will consider an observer who is riding along with this block. So if this block is accelerating towards right, so for this observer, what will happen? There will be a pseudo force which will act in opposite direction, right? There will be a pseudo force which will act in opposite direction to the acceleration. Okay, so pseudo force acts in opposite direction. So first of all, I will draw pseudo force, and now let's draw the real forces. So this is the mass. Okay, so there is normal reaction acting like this. Okay, the normal reaction acts like this, and there is the gravitational force which acts like this. This is the gravitational force, mg. Okay, now we can resolve the normal reaction along two components. Okay, so I will resolve the normal reaction along two components, this component and this component. So this angle was theta, so that's why this angle is theta. Alternate angles, right? This angle is theta, this is 90 minus theta. Okay, so if this is 90 minus theta, this is theta. So this is cos component, n cos theta, and this is n sin theta. So for this observer who is riding along with the block, who is accelerating along with the block, what is this n sin theta doing? So for this observer, there is pseudo force acting on the observer, right? Which is towards left. So there is pseudo force acting on the block towards left. So this n sin theta is balancing that pseudo force. So observer says, I'm at rest. Okay, I'm not accelerating. The world is accelerating in opposite direction. So why am I at rest? It's because of the pseudo force is balanced by this component of the normal reaction. Okay, so again you get same equations, same set of equations. So pseudo force is how much? It is mass multiplied by acceleration, and it is equal to n sin theta. Okay, and how much is n cos theta? So n cos theta is equal to mg. Okay, or I can say mg is equal to n cos theta. And again you divide these two, so you get a by g is equal to tan theta, or a is equal to g tan theta. So again nothing changed, only the perception. So for this observer, what was the normal reaction doing? What was the horizontal component of normal reaction doing? So this observer looks at the block and he sees that the block is accelerating. Okay, so block is getting accelerated because wedge is in acceleration. It exerts a normal reaction on the block. Okay, and the horizontal component of that normal reaction provides acceleration to the block also. Okay, so for this observer, the horizontal component of normal reaction is providing acceleration to the block, while for the observer who is here riding along with the block, accelerating along with the block, what is the horizontal component of normal reaction doing? It is balancing the pseudo force acting on him, and that's his reason that I am at rest. Okay, there is pseudo force acting on me, which is towards left, and the normal reaction, horizontal component of normal reaction is balancing that pseudo force. So all the forces acting on me are balanced, and that's why I'm at rest. Got this? Okay, so there are two ways to solve problems, motion problems. One is using non-inertial frame of reference, and one is using inertial frame of reference.